In this video, we are going to discuss about IIR filter realization using direct form 2. So, in the previous video, we have discussed about the types of realization of digital systems that we have discussed about the direct form 1 realization. So, if you haven't seen that video, you please refer to that video. So, this is what the problem which we have discussed. For this one, we have obtained the direct form structure like this. So in that, if you see, first you have the poles, and the second, sorry, the first one you have zeros, right? So first one is zeros, and the that is left hand side one is zeros, and the right hand side one is poles, right? So here we are going for the direct form 2 for the same problem. So let us consider the digital filter, that is x of z. The transfer function is given by h of z is equal to b0 plus b1 into z power minus 1 up to bm z power minus m divided by 1 plus a1 z power minus 1 up to an z power minus m. So we know that y of z is equal to h of z into x of z. So you substitute the fifth equation in this equation. So you will get y of z is equal to the h of z value from the fifth equation into x of z. Okay. So I can write this y of z. Since from this equation y of z divided by x of z is equal to b0 term plus that is h of z term, right? So I am going to multiply that one with w, multiply and divided by wz by wz, okay, at the right hand side. So you will get y of z is equal to b0 plus b1 z power minus 1 plus bm into z power minus m into wz. So at the right hand side, the denominator we have wz. So if you bring it to the left hand side, you will get wz is equal to, and in the previous equation you have x of z at the denominator of at the left hand side. So wz is equal to x of z divided by 1 plus a1 z power minus 1 plus up to am z power minus m. So if I find the corresponding difference equation for the equation 7 and 8, I will get wn, right? Wn is equal to x of n minus a1 into w of n minus 1 minus w of n minus 2 into a2 up to minus am into w n minus m. This is your ninth equation. Similarly, for eighth equation, if I change, I will get y of n is equal to b0 into wn plus b1 into w n minus 1 plus up to bm into w m w n minus m. Okay, so this is your 10th equation. So from this equation, I can draw the diagram like this. Okay. So here you can see, if I solve the problem, you will get the you will be easy to draw this one. So this diagram is also called as canonical form. Okay. So let us come to a problem. So the problem is draw a direct form 2 realization of the second order transfer function given by h of z is equal to 0.5 into 1 minus z power minus 2 divided by 1 plus 1.3 z power minus 1 plus 0.36 z power minus 2. So why it is second order means because the z power minus value is the highest value is 2. So it is a second order function. So on solving like the previous value, you will get Wn is equal to x of n minus 1.3 Wn minus 1 minus 0.36 Wn minus 2. And similarly, if we find the value of y of n, that is equal to 0.5 Wn minus 0.5 Wn minus 2. Okay. So this is what the direct form 2 realization of the given digital filter. Okay, and this one is nothing but previously we have derived the direct form 1 realization for the same problem. So if you interchange the left hand side value to the right hand side value, so if you check the previous diagram, you can see the left hand side and the right hand side get interchanged. So, okay, so if it get interchanged, you will get the similar diagram, right? So you can see the z power minus 1. Here you have 4 values, but in this one you have only 2 z power minus 1 value, and the number of addition also it get increased, right? Instead of 1 I'm using 2. So if you compare the two structure, you can see the number of delay element in the direct form 1 is twice compared to the direct form 2. Therefore, the direct form 2 is more memory efficient, right? So that is, it will occupy only less memory. So therefore, it is especially used for the floating point implementation. Therefore, it is considered as a canonical structures because it is offering advantage in terms of memory usage, and it has a potential for pipelining in the floating point implementation. So whereas the direct form 1 has it is advantageous whenever we are going for a fixed point implementations in order to avoid the potential overflow issues in the intermediate calculations. So since the direct form direct form 1 requires more memory to store the filter state due to the increased number of delay elements. Okay, so you can see the direct form 1 is a cascade of zero filter followed by a pole filter, whereas direct form 2 is a reverse disorder. Okay, so the direct form 2 is considered as a canonical structure for IIR filter implementation. So what it means is it achieves the same filtering with the fewest possible delays. So if you want to use a fixed point arithmetic, you go for direct form 1, whereas for floating point operation, you can go for direct form 2. Generally, the direct form 2 is better. Okay, but if you are focusing on fixed point arithmetic and if you are more concerned about the potential overflow issues, then direct form 1 might be preferable.